Zombie Apocalypse.
Okay, so this time let's try to apply the concept of singular reinforced concrete beam, but this time, what about if the compression block is an irregular section other than being rectangular? So let's get ready to be neurorized. Okay, suppose that we have this concrete beam and notice that we have a trapezoidal notch. So regardless of what kind of notch is makita natin doon sa beam, basta there is a alteration of an area of being rectangular na walang notch. So therefore that is a topic of an irregular section. So notice that it is under compression, no? Because the significance of having tension at the bottom signifies that the bending that is found on the beam is a positive moment, since we know that it is compression above and tension below for a positive bending to happen. Okay, so that's the case. So then we are given the notches dimension. So this is 50 mm, okay, and then this is 100, and then of course by looking on the dimension, this will become 50 mm also, since the total width is 350 mm. FC prime and FY are given, okay, as specified. So we are to find the following: the height of the compression block, the steel ratio, area of the effective concrete, nominal moment capacity, and what we call the ultimate moment capacity. Yung letter E, usually ito yung kailangan natin makita whenever we design and investigate concrete beam, so that we would know the extent of its limitation of carrying the load itself, no, as being carried by the beam. So let us try to write the equivalent nomenclatures, no, as found also in our NSCP 2015. When we talk about the height of compression block, it talks about the nomenclature A, and steel ratio, that is the rho, okay, or that is what we call the ductility requirement in the other term, no, steel ratio or ductility requirement, okay, or sometimes can be called ductility ratio, okay. The area of the effective concrete, we will use the nomenclature A sub C, nominal moment as the same before, M sub N, and the ultimate moment capacity as M sub U. Okay? So those are the nomenclatures that we are going to use. Okay, so this would be the equivalent stress-strain diagram. Notice that I have shaded green yung area kung saan lang meron tayong height of compression block system, since we are aware that A is most likely less than C because of the system. And then, of course, the stress diagram will be the same. However, you notice that this is not A over 2. Okay? This is not A over 2. The bar Z is not A over 2. So, we will try to understand how do we calculate the bars of Z. Why is it not equal to A over 2, or the half of the rectangular section, where ang tinitignan nyo yatang rectangular, ito, no? Hindi po ito yung tinitignan nating rectangular para ma-denote natin that it is A over 2. Ang main requirement para maging A over 2 is, of course, automatic na rectangular yung basis natin na stress block, at saka dapat ito ay walang uka, okay, yung mismong green area. However, you notice that there is a notch in trapezoidal form. Ito siya, ayan, yan yung pinaka-notch. So therefore, that will invalidate A over 2. So that's why there's a value of bars of Z that is not equivalent to A over 2. The strain diagram will be the same. Ganun pa rin. 0.0 T sa taas and ES is equal to ET. But naging equal yan? Notice that we have only single layer of reinforcement. So therefore, we can say that D is equal to D sub T, as discussed before in the principle and also in one of my discussed problem in the past video lecture. Now, for you to find out it again, kindly view the video lecture regarding the principle of this of investigating and designing single reinforced concrete beam found in my RCD playlist. Okay. Now, what do we need to calculate first? Of course, we need to understand the beta sub 1, or the reduction factor for moment capacity. That is beta sub 1.85. Why? It is less than 28 by the code. Also, to compute for the effective depth D, notice that it will be algebraically calculated. Notice that in the given, the centroidal concrete cover. So why is it centroidal? Notice that it is the 70 mm distance given that is projected through the diameter of the rebar. So that is already the, as discussed in the past video lecture, centroidal concrete cover. Kasi yung concrete cover, yung free from reinforcement, ito yon. Ito yung concrete cover. Kaya kung tatanungin tayo for this given, ano yung magiging possible concrete cover, just 70 minus half of 20, kasi kalahati ng bakal, which is 60. Ngayon, notice na meron pa tayo kasi usually idadagdag, yung tinatawag nating stirrups, na may mga diameter kan dapat idagdag. So that will be one of my next discussion. Okay? What if, of course, sa totoo sila, may dapat na ano yan, na syrups. So, but of course, for the sake of analysis, let's try to find out muna yung walang syrups. Okay? As a disclaimer. And also, the steel area, meron tayong 5 pieces at 20 mm diameter. So that's why we resolve to this equation. Okay, so itabi lang natin yung tatlong values na kailangan natin mamaya. Now, ganun pa rin yung assumption natin. Let us assume that it is under-reinforced. So, pag sabi natin under-reinforced, Fs is more than equal Fy. So, pag yan na nangyari, then you have to set that Fs equal to Fy. Reason is, no stress should be more than yielding. Kasi yun na mismo yung pinaka-yielding o yung gumalaw na. But theoretically, it can be more than the yielding kasi yun yung mismong paggalaw. So, therefore, Fs equal to Fy. But, bakit nagkaroon tayo ng second assumption? Now, why second assumption? We don't know where A will rely on, no? Pwede kasi dito. Okay? Pwede naman din dito. So, yung sa loob ng notch, okay? Na may parang triangle. Okay, in better view. Yan. Okay, kasi may banibagong function geometrically. Okay? Nung uka. So, therefore, may assumption muna. Pinalagpas ko ng 100. Bakit 100? Kasi in the given, this is 100. This is 50. Okay, and then ito ay 50. Ang tiningnan ko dito ay yung 100 mm, pinalagpas ko siya dyan. Ngayon, kung sakali nagkamali assumption, then we can correct it later by introducing another figure na, kung say, if less than 100 na ipalabas natin, but more than 50 naman, so ito i-analyze natin. Parang ito yung pinaka-visualization. Dito ka magka-cut portion. If in between 50 to 100 yung makukuha natin. So that's why ito i-analyze natin. Yan. So gagawa ka ng algebraic situation, a setup, para makalculate yan. So I think it's easy naman on how to deal with it. So that will be a function of A, you know. And then play role ka na lang sa distance of, let's say, anong gusto mong variable. Let's say distance of yung wala pa, K. Yan. Then you can play with it. So parang geometrical reorientation do the same. But the main concept is this. Okay? The main concept, I need to assume that first na A is more than 100, then I'll check these two assumptions. Tandaan nyo, assumption number 1, assumption number 2. Kailangan para masabi natin acceptable yung sagot ng mga height of compression block, which is A, at saka Fs na talaga more than Fy, dapat both of them is satisfied. Ano? No assumption should be left behind. At hindi po pwedeng assumption mo isa dyan ay mali and then the rest are tama. Kailangan dito, lahat ng assumption ay tama para ma-accept isang set of answers. Okay? I think it's clear. So therefore, A is more than 100. So para ma-check natin yan, let's verify it later. Again, we start with sigma C is equal to sigma T. And again, 0.85 FC prime AC times ASFY. Kasi A sub C, yun yung color green. Yan yung tawag nating area of the effective concrete under compression. So therefore, where AC can be calculated as what if buo muna, 350 times A, then minus the notch, which is a trapezoid. Okay, so ganun na naging discarte muna natin dyan. Ibabawas lang na natin muna itong trapezoid na to. Yan. So by that sense, then we can now calculate as A sub C is 350 times A minus trapezoid area, that is average basis times the perpendicular width, which is 50 plus 100 over 2 times 50. Then we will get this area calculation for compression concrete as effective. So ito yung stress block na tinitingnan natin. Kaya naging bar sub Z yan. Kasi kung tignan yung volume block niya, pag sasamahin mo yung stress at saka yung cross-sectional area niya, ito yung mabubuo nating figure. Okay? This one. So therefore, what will happen is, itong distance na to, yan, I'll make it red para mas madali makita. This one. Yan. At yung 4C na yan, sa 3D volume block, yung pagitan distance yan, yan yung bar sub Z na nakikita natin dito sa taas ng diagram. Okay? So, yan yung kailangan natin ma-address later para pag naging finalize na yung value na A, then we now calculate bar sub Z. to complete the nominal moment. So in continuation, just replacing the equation of A sub C inside this phrase, so we'll yield to this equation. Then the only unknown is A, no? If you notice, then we can now calculate what is A. So A can be 116.5691 mm. That is more than 100 mm. So therefore, the second assumption is correct. But we cannot say that this is the true A ulit na sagot dito, no? Hindi pa tayo sigurado diyan kasi hindi pa tayo sure kung masasatisfy natin yung first assumption na Fs is more than equal to Fy to make Fs is equivalent to Fy. So how to check that? Using the strain diagram that we have performed before in the principle of singly reinforced concrete beam and also in the past video lecture, pinakita ko na yung derivation nito. Yung Fs is equal to 600 over C quantity D minus C. Okay, already shown kung paano. Then, if you miss it out, kindly go back to the video lecture that I presented before. Okay, so how do we calculate to use that? Now, note that A is equal to beta 1C. Okay? And then C is equal to A over beta 1. So, we can get this one. So, tandaan po ninyo, andito yung beta 1 value natin na 0.85. Okay? So, then followed by computing Fs. So, substituting all the values. So, plug in no, yung mga DNC value, then we can get 1062.5331 megapascal, which is way beyond, above, Fy. So, therefore, the assumption is correct for the first set. So, this is true. No? Totoo pala ito. Now, notice, there are only two assumptions, number 1 and number 2. And since both of them are correct, then we can now accept the answer for the height of compression block to entertain letter A. Okay? So, that's the time that I will accept. And then finally, we can now calculate the reduction factor. So, by performing the calculation of the maximum tensile strain, or sometimes call it as a net tensile strain. So, and again, this equation is derived already do sa ating past video lecture. So, kindly go back to our video lecture if you miss it out para mas maliwanagan kung paano naging ganyan. So, therefore, you can now get 5.3127 times 10 to the negative 3, or in short, that is 0.0053. Now, notice it is more than 0.005. Okay, so therefore, that is under tension control limit, already discussed in the past video lecture. Then we can say that it is a reduction factor of 0.9 to be used, no, to evaluate the ultimate moment capacity taken from the nominal capacity. Okay. Now, rho is computed as AS over BD, where rho, again, is the steel ratio or ductility requirement or ductility ratio. So, computing AS, yun ang formula niyan, and B and D, okay? So, you can get 0.01181 without a unit because unitless po siya. Since AS in terms of square millimeter, and BD is also in terms of millimeter squared when multiplied. Okay? And then the area of defective concrete, if you notice, meron tayong formula na dito. Substitute mo na lang yung value ng A. Plug in nyo na lang po dyan. Then you will get 37,049.188.73 millimeter squared. Now, that is the answer for letter C. Now, what remains is D and E only. So, madali na yung susunod. So, before that, you notice that if I take a moment on T, then C will rotate, no? Multiplied by the perpendicular distance of D minus bars of Z. Likewise, if I take a moment on C, no? Dito naman, hawakan natin itong C. So, iikot naman yung T, okay? Then, perpendicular dun sa C, na D minus bars of Z. So, the dilemma is, ano itong bars of Z na yan? So, what if we take a look on this area in the green shade as well as you look on the 3D block, no? Ito yung makikita. So, therefore, there's anong bars of Z. Nakatumbok yung bars of Z na ito dito. Nakatumbok yan. So, therefore, yan yung nire-represent noong figure na yan. So, to calculate bars of Z, what I want to do is this. Maraming way, no? Using Varignon's theorem, yan ako magkitake ng moment arm sa taas na yan para dumikit na yung bars of Z. And then there's so it's up to you to use statics of rigid bodies. So let me present how do I solve with it using Varignon's. So, tandaan nyo, meron tayong componential equals resultant. So, gagawin ko dito, i-divide ko muna ng dalawang area. So, mapapasin po ninyo na meron tayong dalawang mag-generate, isang right triangle, at saka meron tayong isang isosceles triangle. Okay? Now, whose dimensions, if you check the values here, so this will become 50, this is 100, okay, and 50 yung nasa taas. Okay, ito. Yan. Now, how do I calculate that? So, AC bar sub Z as a resultant equals components. As if wala mo ng uka, okay, 358 times A over 2, kasi centroid dati, papupuntay natin lahat sa taas. Then minus, let's take a look on this right triangle. Ito, yung colored violet. So, ang centroid nito, going to that is papunta dyan. So, that is 50 height. So, 50 over 3. You are aware that if you have a right triangle, so ito is just 1/3. Okay? 1/3 of the dimension of the length. Okay? Let's say this is L. Okay? Let's say this is L. So therefore, and then the remainder, of course, you know that this is 2/3. Okay? 2/3 of L. So that's why it is 50 over 3. Minus this isosceles. Papupuntay natin din ulit sa taas yan. Okay? So therefore, minus 100 times 50. And then, of course, pag isosceles, pag ito ang kinuhanan natin, yan, is as good as 1/2 lang naman, no? That is 1/2 of L, if this is L. Yan. So this is L, no? So we will get bar sub Z is 60.2477 mm. Kasi may value A sub C, i-divide mo sa lahat yan. So to get bar sub Z. What if we do the other way, no? Ganun pa rin. Usually, ito yung iniisip ninyong solution, ano? Ganito ginagawa natin usually. Ginagawa nyo yung dalawang area na isang rectangle tsaka isang triangle. So, it is also correct. Wala namang mali doon, no? Pares lang naman ang magiging sagot. So, ito yung una, rectangle. And of course, the next area is a right triangle. So, ganun ulit. So, again, this is 50. This is 100. Pero yung buo, no? The whole is 100. So, what remains, ito is 50 lang, ano? This is 50. So, therefore, ganun ulit, 58 times A over 2 kasi buong rectangle minus binawasan. Unahin natin yung area ng rectangle. So, nandito, di papupuntay natin dito. Which is, we are aware that it is 1/2 of the distance 50. Minus area of the right triangle, which is minus 1/2 of 50 by 50, multiplied by, papupuntay natin yung centroid na to, papunta dito. So, which is composing of, parang ito yung triangle, tapos ito yung cut, na ito yung 50, okay? Tapos ito, may distance siya pang 50/3, okay? Kasi in orientation na ng geometry. So, you'll get this. And then, it is the same answer that you will get. Bar sub is 60.2477. Then, we can now calculate the value for the nominal moment. So, therefore, if I take this into an account, so let me take first C times D minus bar sub Z. So, plugging in all the important values, but of course, converting it into kilonewton meter. So, I'll get 208.4403 kilonewton meter. Likewise, if I do the other way, computing T times D minus bar sub Z, so this one, plugging in the values, so you'll get the same answer. Okay? So you notice either of the two will give you the same answer. So the answer for the nominal moment under the question of letter D is 208.4403 kilonewton meter. Now, to take the full answer for the ultimate moment capacity, that is taken times moment nominal, then recall that the phi is 0.9, okay? And the nominal moment is the 208.4403. Then finally, we will get 187.5963 kilonewton meter as the ultimate moment capacity, or simply the capacity to resist ultimate loads. So that's how we deal with a singly reinforced concrete beam if the section under compression area, I mean, is irregular area. So I hope you learned something new today. Thanks for viewing, and as a tradition, you have been Eurorise, and I hope to see you in our next video lecture. So our next topic would be, what if the reinforcement is missing? But how can we calculate the moment capacity of the given section? That will be the next question. Now, that will be the introduction why steel ratio is now very important in that said calculation. And also, what is there any codes that will be used as a minimum basis or a maximum basis to limit the area of the reinforcement? So that is our next objective to look out. Okay, so see you in our next video lecture.